All right, 7th graders, today we're talking about independent and dependent events. Your central question is, can you identify dependent and independent events? So, first we need to write down what an independent event is. Let me get my official definition. An independent event is the occurrence of one event does not affect the next event. And you'll see what I mean about that really quickly. A dependent event. So, dependent does affect the next event. And I think it's easiest to talk about these using examples. So, independent, when you think about independence, you are fine on your own. You're not affecting something else. You don't need somebody else. Dependent, you do need somebody else. You need to know what happened before your event happened to find the answer. So, tell whether the events are independent or dependent and explain. You must write something that tells me why. So, you flip heads on one coin and tails on another coin. So, does flipping heads on one coin affect flipping tails on another coin? It does not. So, they're independent. Because the outcome of the first event doesn't affect outcome does not affect the second coin toss. So nothing about that first coin toss affects the second coin toss. Your teacher, that's me, chooses one student to lead a group, and then chooses another student to lead a group. So, if I choose Christian to lead a group, is he available to lead the second group? No. So, these are dependent because it does matter who I would choose first, because they're now no longer available to lead another group if I want them to. So it's dependent, and that's because there's one less student to choose from. Next one, you choose a blue marble from a bag and set it aside. Then you choose a green marble from the bag. So, after you choose a blue marble and you don't put it back in, there's one less marble to choose from, right? I mean, especially if there were only 2 marbles in the bag, then that would make a big difference. But if you take 1 marble out and don't put it back, it's dependent because there's 1 less marble. You guys are short a lot of marbles, but 1 less marble in this case. So if you choose a marble out and then put it back, that would be independent because all the same marbles are there from the first choice to the second choice. But on this one, you're taking one out and not putting it back, so it's dependent. And the last example, you roll a 5 on a number cube and spin blue on a spinner. So if you roll a number cube, would it have any effect on what you spin on the spinner? No, so that's independent. Because a number cube does not affect spinner. Alright, on to the next page. How do you find the probability of independent events? So you find the probability of the first event and you multiply it by the probability of the second event. And this second one, I wrote a capital P with some parentheses. That's a probability notation. So it just means that you're finding the probability of the second event. So whatever you see in parentheses is what you're finding the probability of anytime you see that P and then parentheses. So let's try some probability problems. You flip 2 quarters. What is the probability that you flip 2 heads? Well, first quarter, the probability of flipping heads would be 1 out of 2. And the second quarter, the probability of flipping heads would be 1 out of 2. And I said up here that we just multiply them. And multiplying fractions, I multiply straight across and I get 1/4. So the probability of flipping heads and then heads on a quarter is 1 in 4 chances. Next one, you flip 2 coins. What is the probability that you flip 1 heads and 1 tails? Well, on the first coin, the probability of flipping heads is 1 out of 2. And the probability of flipping tails would be 1 out of 2. So the total probability of flipping 1 heads, 1 tails is 1 out of 4 also. You flip a coin and roll a number cube. What is the probability that you flip tails and roll a number less than 5? So the probability of flipping tails would be 1 out of 2. And the probability of rolling a number less than 5 would be 1, 2, 3, and 4. So that would be 4 out of 6. And once again, when we find a probability, when we multiply fractions, we multiply straight across. 1 times 4 is 4, 2 times 6 is 12, and I can reduce that to 1 in 3. The probability of flipping a coin and rolling a number cube, flipping a tails and rolling a number less than 5 is 1/3. Alright, how do you find the probability of dependent events? The exact same way you find the probability of independent events. You find the probability of the first event multiplied by the probability of the second event. Alright, you randomly choose a flower from the vase to take home. Your friend randomly chooses another flower from the vase to take home. What is the probability that you choose a purple flower and your friend chooses a yellow flower? So, let's see. The probability of choosing a purple flower. So here are my totals. 7 out of how many flowers total? Looks like 28. Now, your friend took that flower home. It's gone forever. It's never going back in the vase. So now there are 6 purple flowers. So the probability of the second event happening is out of a total of 27 flowers because we've taken one purple one out. And your friend is choosing yellow, but there's still 9 yellow. So it would be 9/27 is the probability of the second event. And we multiply those. Now, I would highly, highly, highly recommend you recall or relearn or remember some way multiplying fractions and simplifying or cross-reducing. 9/27 can be simplified. Both can be divided by 9 to 1/3. 7 and 28 can both be divided by 7. 7 divided by 7 is 1. 28 divided by 7 is 4. And now I have a really simple multiplication problem. I get 1/12. And on the last problem, what is the probability that both flowers are purple? Well, the probability of the first one being purple is still 7/28. But now I have 27 flowers for my second choice. And I used one purple one, so now I have 6 purple ones left for my second choice. And I would still cross-reduce. 7/28 can still be changed into 1/4. And then 6 and 27 can both be divided by 3. So we would get 2/9. And 1 times 2, or we can actually cross-reduce this. And that would make it even simpler. So 2 and 4 can both be divided by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So now I get 1 times 1 is 1. 2 times 9 is 18. So the probability of getting both purple flowers is 1/18. Alright, the last 6 problems are for homework. Make sure you get those done. And I do have special messages from our friends in the 7th grade. Anybody want to say hey? Any special messages?
Hello.
Do your homework.
Hi, Elise.
Do your homework or you will
Hello.
You will suffer the wrath of Miss Thornton if you don't do your homework.
True. We are missing some friends. Maybe I can draw them in.
Draw Elise and draw Brianna.
One of them is blue. Let's see. Who's taller? Brianna?
Brianna's taller than everybody.
Always smiling Brianna. We love you and miss you. Elise, my favorite color will be green. You'll be a little bit shorter, Elise. There you go. Beautiful Elise. Getting braces. Sad face. That's yucky. Okay.
No, you don't.
Draw a neon cat.
A neon cat. Let's see. That's probably the best color. Well, now you can see that my cat drawing skills.
Yay.
It's for Molly, so it won't be that hard.
My cat's kind of like, that kind of looks like my dog Zoe, though.
Why my face?
It's okay, Brianna's heading. Hello.
Sorry, the cat's standing on your heads.
Aww.
Aww.
I'm wearing Robbie's glasses.
Yeah. That's a surprise.
All right.
Goodbye.
Have a great night.